Dear students, welcome to the maths class MA8491 Numerical Methods. Unit number 5 Boundary Value Problems in ODE and PDE. In this class, we discuss the solving one-dimensional heat equation in implicit method, rank-Nicholson method. One-dimensional heat equation. There are two types. The first one is explicit method. In the previous class, we discussed in the Bender-Smith method. In this class, we discuss implicit method is rank-Nicholson method. Now, the one-dimensional heat equation is Uxx equal to AUT, where lambda equal to K divided by AH square. H is the step size of X, K is the step size of T. The rank-Nicholson difference scheme or method for one-dimensional heat equation is lambda into ui plus 1 comma j plus 1 plus ui minus 1 comma j plus 1 minus 2 into lambda plus 1 into ui comma j plus 1 is equal to 2 into lambda minus 1 ui comma j minus lambda into ui plus 1 comma j plus ui minus 1 comma j. The left hand side fully in the j plus 1 row, right hand side is in the jth row, the latest two rows. Here the values. Here the first one and the last one by multiplied by lambda minus 2 times of lambda plus 1 into the middle one is equal to 2 times of lambda minus 1 into ui comma j, or it can be written as 2 lambda minus 2. This can be written as minus of 2 lambda plus 2 to multiply into inside. There is no problem. Okay, then right hand side is 2 into lambda minus 1 into ui comma j minus lambda into the first one and the last one. Here. Okay. If not, if lambda equal to 1, that means if k is not given, now we choose lambda equal to 1. If lambda equal to 1, then lambda is the value of k divided by ah square. So lambda equal to 1, which implies k equal to ah square. K equal to ah square. The rank-Nicholson formula 1 is reduces to lambda equal to 1. Then this term will be 0. This term will be 0. This term is minus taken and simplify to ui comma j plus 1 equal to 1 by 4th of ui minus 1 comma j ui plus 1 comma j ui minus 1 comma j plus 1 ui plus 1 comma j plus 1. This value is equal to 1 by 4th of these four corners. 1 by 4th of these four corner values. It is known as simplified rank-Nicholson formula. Simplified rank-Nicholson formula is derived when only lambda equal to 1. K is chosen as a into h square. Problem. Use rank-Nicholson scheme to solve dou squared u by dou x squared equal to 16 into dou u by dou t 0 to 1 and t greater than 0 given u of x comma 0 equal to 0. That means it is the initial condition. Since t equal to 0, so it is initial condition. The boundary conditions u of 0 comma t equal to 0 and u of 1 comma t equal to 100 t. These two are boundary conditions. This is initial conditions. Compute u of x comma t for one time step, taking del x equal to 1 by 4. This question asked for 2 times, November 19 and April 19, 8 mark. Given one-dimensional heat equation is Uxx equal to 16 ut. compare with UXX equal to AUT. So A equal to 16. Here X varies from 0 to 1 since 0 to 1 are in the boundary conditions u of 0 comma t, u of 1 comma t. So X varies from 0 to 1 with the step size del X equal to 1 by 4. That means H equal to 1 by 4. 1 by 4 is 0.25. So X value taken from 0 to 1. So 0, 0.25, 0.50, 0.75, 1. So I is 0 to how many values? Total of 5. So it is 0 to 4. Since the value of k is not given, so let k equal to 1, which implies lambda equal to 1, which implies k equal to a h squared. A is 16, h is 1 by 4, so h squared is 1 by 16. 16 16 cancelled, so k equal to 1. We have to find the value of u at one time step with k equal to 1. So t equal to 0 and 1. So j is 0 comma 1. Using the boundary conditions, means x equal to 0 and x equal to 1. U of 0 comma t equal to 0. So the first column will be 0. The another one boundary condition is u of 1 comma t equal to 100 t. So we put the values for t. Here t equal to 0. So put t equal to 0, we get 100 into 0 is 0. So u of 1 comma 0 equal to 0. U of then t equal to 1. Since t values 0 and 1. So 100 into 1 is 100. So u of 1 comma 1 is 100. It is the last column. Then the initial condition u of x comma 0 equal to 0. That means u of I comma 0 equal to 0. The initial condition is the first row. First row full and full 0 only. The remaining values can be calculated by the rank-Nicholson formula. U of I comma j plus 1 equal to 1 by 4 of the 4 corner values. Now we have the following table. X values 0 to 1 with increment 0.25. So x equal to 0, 0.25, 0.50, 0.75, 1. That is I equal to 0 to 4, 0 to 4 only. T equal to 0 and 1. So j equal to 0 comma 1. I change it to 0 to 4, not 5, 0 to 4. Sorry for the mistake. I equal to 0 to 4. Here the first column is 0, the last column is 0 and 100. The first row will be 0. The four corner values are 0, 0, 0. So these three values we want to find out. Now this u1 by the rank-Nicholson formula, u1 equal to average of the four corners. That means 1 by 4 of 0 plus 0 plus 0 plus u2, which implies u1 equal to 1 by 4 u2, which implies 4 u1 minus u2 equal to 0. The second one, u2 equal to 0, 1 by 4 into 0 plus 0 u1 plus u3, u1 plus u3. So 4 u2 equal to u1 plus u3, which implies u1 minus 4 u2. This 4 u2 taken to right side. So u1 minus 4 u2 plus u3 equal to 0. So u3 equal to 1 by 4, u3 equal to 1 by 4 of 0 plus 0 u2 plus 100. So 4 u3 equal to u2 plus 100. Then 4 u3 taken right side, 100 taken to left side. Therefore the u2 minus 4 u3 equal to minus 100. Solving these equations by using Cauchy or by elimination method, we get u1 equal to 1.78 57, U2 equal to 7.1429, U3 equal to 26.7857. That's all. It is the first problem. The second problem solved by rank-Nicholson method. The equation Uxx equal to Ut subject to the conditions U of 0 comma t equal to 0. It is the boundary conditions since x equal to 0. Here x equal to 1, so it is the another one boundary conditions, and u of x comma 0 equal to 0 for two time steps with h and k are given. Here uxx equal to ut compare with a equal to 1. X varies from 0 to 1 with the increment h equal to 1 by 4, so 0.25, so 0 to 1, this I equal to 0 to 4, given k equal to 1 by 16, so lambda equal to 1. So we use the Crank-Nicholson simplified formula u of I comma j plus 1 equal to 1 by 4 into this one. Given that we have to find u of x comma t up to 2 time steps with k equal to 1 by 16. So t equal to 0, 1 by 16, 2 by 16. So j equal to 0, 1 and 2. The boundary conditions u of 0 comma t equal to 1, which is the x equal to 0. So it is the first column. So the first column full value is 0. Here x equal to 1, comma t equal to t. The values of the last column are put t equal to 0 and 1 by 16 and 2 by 16. So u of 1 comma 0 equal to 0, u of 1 comma 1 by 16 equal to t, that means 1 by 16, u of 1 comma 2 by 16 equal to 2 by 16. Given the initial condition is u of x comma 0, means initial condition is t equal to 0, so the first row full values be 0. Here the first column will be 0, the last column is 0, 1 by 16 and 2 by 16. We want to find two rows, additional two rows, so two time steps. So u1, u2, u3, u4, u5, u6. So we want to find out six values. First we find out u1, u2, u3. Then using u1, u2, u3, we find u4, u5, u6. Here two times we use the Crank-Nicholson formula. Now first set we want to find out u1, u2, u3. It is the Crank-Nicholson method. So u1 equal to 1 by 4 of 4 corner values. Then u2 equal to around the 4 values. So which implies we get the three equations 2, 3, 4. Solving these three equations we get u1, u2, u3. Using this u1, u2, u3, we find out u4 as 1 by 4 of 0, u2 plus 0 plus u5. We already known u2 equal to 0.045. So put u2 equal to 0.045. Then simplify this. For u4 minus u5 equal to 0.0045. Similarly, we find out u5 and u6 with the other two elements and constants. So we get the equations. These 5, 6 and 7. Solving these 5, 6, 7, we get u4, u5, u6. Hence the answer. We calculate u4, u5, u6 using by calculator, solving the three unknowns method. Okay. Similarly, the third problem. In this problem, lambda equal to 1 by 4. So lambda equal to 1 by 4, we use the main formula, not simplified formula. Here u of x comma 0, that means the initial line, that means first row is given by sin pi x. 0 comma t equal to 0 and u of 1 comma t is 0. So the first column and the last column will be 0. The first row is calculated by sin pi x. So x equal to h equal to 1 by 3 from 0 to 1. So 0, 1 by 3, 2 by 3 and 1 is 0, 1, 2, 3. J is 0, 1, 2. Since k equal to 1 by 6, 2 time steps. So 0, 1 by 16. The next value is 2 by 16. Now u of x comma 0 equal to sin pi x. So x equal to 1 by 3, then this value is sin pi by 3. Sin pi by 3 is 0.0866. Using this value in the radian mode, not degree mode, using by the calculator in radian mode. We know that sin pi by 3 is sin 60 degree is root 3 by 2, or find out the value root 3 by 2. Similarly, sin 2 pi by 3. 2 pi by 3 means 2 into 180, that is 360 by 3, that means 120. 120 is also root 3 by 2. So 0.8660. Then, so first row, first column, last column. So we want to find out these four values only. First one, u1. u1 is calculated by the rank-Nicholson formula, not simplified rank-Nicholson. It is the rank-Nicholson formula. Lambda into ui plus 1 comma j plus 1 plus ui minus 1 comma j plus 1 minus 2 into lambda plus 1 ui comma j plus 1 is equal to 2 into lambda minus 1 into ui comma j minus lambda into ui plus 1 comma j plus ui minus 1 comma j. Here put lambda equal to 1 by 4, we get lambda equal to 1 by 4. Lambda plus 1 is 5 by 4, lambda minus 1 is minus 3 by 4. Here the calculation is done here. Solving this, we get ui plus 1 comma j plus 1 plus ui minus 1 comma j plus 1 minus 10 into ui comma j plus 1 equal to minus 6 ui comma j minus ui plus 1 comma j minus ui minus 1 comma j. So apply the equations to the second row. For the u1 element, we use these conditions. We get ui plus 1 comma j plus 1 mean for this condition it is ui plus 1 comma j plus 1. This 0 is ui minus 1 comma or for the u1 element, put I equal to 1 and j equal to 1. Put I equal to 1, j equal to 1. It is the very difficult one. So we use the conditions. It is ui plus 1 comma j plus 1 is the second row next to the current element. That means u1 element. It is the previous one element. It is the current element. It is u1. It is previous value for u1. It is the next value for u1. So next value for u1 is u2. Previous value is 0. The current value is u1 is equal to minus 6 into ui comma j. That means about to the u1. It is next to the right side value in the previous row. It is the left side value. So it is the u2. Here the I comma j plus 1 is minus 10. I comma j is minus 6. The other two elements are plus. Here other two elements are minus. So here u1. So minus 10. Other two elements are plus. Here about the u1 is 0.866. It is minus 6 times. Other two elements are minus. So we simplify this equation. For the element u2, we get these equations. Solving these two equations, we get u1 equal to 0.6736. Similarly, apply the equation. That means applying the formula to the third equation. Sorry, third row. For the u3 element, u4 element. Solving these two equations, we get u3 equal to 0.5239 and u4 equal to 0.5239. So, thank you.